So with this, these questions here, we've got O to A is a vector known as A, little a. Okay, so the way it's done it here is if the O to, we see this when we're talking about lengths. If I just wrote OA like that, I would be referring to the length O to A. If I do an arrow over the top, I mean a vector going from O to A. And in that particular direction. So, as I mentioned in the first video, I've got the arrow the wrong way around, and it's very thick. As I mentioned in the first video, once you've got this vector, you can move it around any way you want. It is still vector A, okay? That's the important thing to note. Why can't I? Okay, hang on, I use. Sometimes the pen acts differently to the mouse. Okay, there we go. So that is vector A, which means from B to C is also vector A. From C to D is also vector A. From A to E is also vector A. Now, it looks like it is by sight, but how can I be sure? Because it tells me that OBDE and OAFG, so OB, where is it? DE. Okay, so that whole thing is a parallelogram, and OAFG is a parallelogram. So these other ones in the routine are also parallelograms. All right. Anyway, so it means that is a vector, and O to B is also a vector named B. So let's identify that as well. Obviously, in an exam or in any sort of exercise like this, you can't draw an arrow and then move the arrow around. So I'm kind of like using a technique which you can't actually do other than when you're on an online or electronic whiteboard. But just to demonstrate the point, so O to C, give your answer. So we're trying to get from O to C, and what we can do with vectors is we can add them in the same way as you would add anything else. So if I say that's A, that's, oh wait a second, that's not A, is it? That's B. B. You can see that I can get from O to C by using A and then using B. And so the vector is A. The answer is A plus B. Now, mathematically, that should be the same as B plus A. And if we look diagrammatically, we can see that it is. If I did B first, followed by A, I would still get to C. So it doesn't really matter how you do this. Now, I'm just going to also demonstrate one other thing, just to show you again how mathematically they work just as they do geometrically. Let's imagine I took the long route. I went A, another A, and then a B, and then I did negative A. So I went backwards. So I flip that one around, and I'm going to write negative A. So what I'm doing this time is I'm going to go A plus B, take away A. And you'll see that because we've got A take away A, they cancel, and we're back down to A plus B. So it still works the way it would do normally in algebra. Anyway, either of those two answers are fine. So B to A, I think you might be able to work out the rest of these yourself now. So I'm going to get rid of some of this. I'm going to stop the video, and then I will get rid of some of these answers and let you do the rest, to be honest.